So introduction to the non-ferrous metals practices over here. Okay, so the ferrous metals are the iron contents and the non-ferrous metals are the non-iron contents metals. So usually you have all known. Okay, so in this non-ferrous metal contents in your syllabus as per your syllabus point of view, and today we are going to discuss regarding the aluminium material. Okay, the aluminium is contents which is having a non-ferrous materials. Okay, so related the aluminium, how does the aluminium castings are been removed, and what are the alloys are been used for the improving the mechanical properties of an aluminium, that we are going to studies, and the foundry practices. Okay, now let us see the advantage and the limitations of the aluminium casting. So there are some few of the advantage and limitations are there, so I will highlight some few of them. Of all the non-ferrous casting, the aluminum casting exhibits the high strength to the weight ratio. Okay, so it is having the strength, good strength regarding to its weight. Okay, so this is what the advantage of the aluminum casting. Aluminum casting alloys displayed excellent flowability characteristics for the casting than the section of the fine details. Okay, so this is also the one of the advantage. Aluminum casting alloys display an excellent flowability. Flowability means what? The movements of the liquid fueled in the mold casting. Now third one, aluminum casting alloys melts at an relatively low temperature, thereby reduce the problem related to melting. Okay, aluminum casting alloys melt at relatively low temperature. Within a less temperature it can be built, because its melting point is very less. It doesn't require some high temperature furnace. For like this way, the furnace and whatever the pouring cups, scrutables, and the melting related problems are there, which has been reduced. No such problems are coming comparing to the ferrous metals. Okay, now let us see some of the limitations. The aluminum castings are more expensive than the ferrous metals, uh, because the initial thing over here there is that the raw material of that casting, that is an aluminum, and the non-ferrous metals are very costly compared to the ferrous metals. Okay, so this is what the major one uh, uh, expensive thing in the casting purpose. Now second limitation, we will see the aluminum casting exhibits a proper poor resistance to an abrasives and the wear. So see over here, the aluminum casting is having a pure resistance, abrasions, and the wear, because the strength of the aluminum casting is very low, and it is most probably the ductile material, so it is having the maximum wear capacity and the abrasions also. Okay, so this is what some of the limitations of the aluminum casting. Now let us go with the melting of an aluminum alloy. Melting of an aluminum alloy. So see, the simple furnace is there for melting the aluminum alloy. The small capacity furnace you can use, either it may be the crucible uh, crucible cup pit furnace, you can see open earth not open earth furnace, the ground pit furnace, you can use the direct or indirect arc in a small quantity of the furnace, you can see, or the induction furnace which is having the crucible coil, uh, crucible with an electrical, surrounded with an electrical coil. Such types of furnace you can use. So the most commonly used such type of lift out type crucible furnace, so name itself indicates that the crucible cup is been lifted out by the furnaces. Now there is a simple diagram over here, or the you can see by this help of diagram the furnace. Okay, we'll go for the construction. Over here you can see there is an refractory walls, there refractory linkings are there, and over here this is an crucible cup is there, in which the raw material is been charged, that is an furnace charging is there, where the aluminum raw materials are been added, and over here there is a torch is been used for the supply of an flame. Okay, by which the fuel gases are being used. Okay, now over here at the top you can see the cover. Now let us see the working. This is what a simple construction. Now let us see the working of this one. So the cover is been opened first initially, and the crucible cup is been placed within this furnaces. Okay, by having the bottom support. In that crucible, first initially they have been put some aluminum parts. Okay, solid scrap parts, that is called as a furnace charge, which has been placed. Then afterwards, with the help of this nozzle, the fuel gas is been introduced within this chamber, okay, within at the tip of this nozzle it has been ignited by the matchbox or the any of the lighter. Okay, then afterwards when it ignites with the help of the gas or the air fuel gas mixture, okay, oxygen or any fuel gas, you can take a acetylene or methane, okay, these types of gas are being used, okay, by oxygen and this type of fuel gas mixture, it has been ignited, a flame is being generated. With that help of the flame, the heat is starts to generated within this chamber. It has been closed, so vacuum chamber is been created. Within that vacuum chamber, heat starts to generate and allows the solid aluminum parts which are being kept in the crucible to melt over there, allows it to melt. Once the aluminum is been completely melt with its alloy in the crucible, the cover is been opened and the operator lift the crucible by with the help of a tongue and take that crucible to the pouring towards the molding box, and it pours into the mold cavity. Okay, this is how the process of an lift out crucible furnace has been done. Okay, and aluminum casting is aluminum raw material has been melted. Okay, this is one of the example of the furnace which is used for the aluminum melting purpose. Now let us see the hardness which used in the aluminum casting. So see, the aluminum casting, purely aluminum doesn't have the proper hardness and the strength because its mechanical properties change. To give the strength to that casting, that to improve the hardness of that casting, to improve the mechanical and the physical property of the aluminum of casting, during the melting purpose some of the alloys are being added for giving the change of the mechanical and the physical property of that casting. Okay, so that alloys which are being used, the one point is to be considered that the melting point of that alloy should be less than the melting point of the aluminum. Okay, if it is higher than the aluminum, it doesn't fused with the aluminum molten metal or mixed with the aluminum molten metal. This is the important point which has to be keep into consideration during the selection of an alloy which is being used for the hardness of the casting. Okay, the next one, there is an improper calculation is that the ratio is there. According to on that basis ratio, the alloys are being added to the aluminum due to the during the melting purposes, so that it can melt properly and mixed with the aluminum and get the desired properties. And these types of alloys are called as an master alloys. So which are the alloys are being used during the for improving the mechanical and the physical property of the aluminum casting, that we'll see. For example, the chromium, magnesium, zinc, uh, chromium, magnetite, okay, nickel. These are some of the alloys which are being used in the aluminum for improving the hardness. For example, the chromium has a melting point of about 1875 degrees Celsius, is used as an hardener with the aluminum melt in order to impact the strength and the hardness and oxidation resistance. Okay, so this is the some of the alloys which are being used for improving the hardness of the aluminum. Now next, let us see what is a drossing. The drossing is nothing, in simple way I would like to explain you. When you boil the milk, when the milk has been boiled, okay, for longer time, okay, at that moment what happens, the upper surface of the milk is coming up with a skim, that is milk skim is coming out. So like this way, when you melt the aluminum for a longer time, okay, if the aluminum is melted for a longer time, it has been introduced by the heat for a longer time, the upper surface of the aluminum comes with the contact with the atmospheric conditions, okay, due to which the chemical reactions occurs, and one small layer is being generated, that is maybe not in a complete solid, not in a liquid form, semi solid form, a layer is coming, that layer is called as a dross. Okay, so this dross can be minimized, by melting the aluminum in a faster rate instead of melting it in for a longer time. Okay, by putting a flame at a high speed, you can melt in a faster rate instead of putting a flame in a smaller size and take a longer time for the melting of an aluminum. Then next is the that dross which has been on the upper surface can be removed, and it can be reused for the another purposes. Okay, so these dross are been reused by two methods, by chemically and by mechanically. By chemically, some of the chemicals have been added for the dross, that aluminum oxides is been added, and by with the help of these gases, okay, gaseous fluxes containing chromium chlorides and fluorides are being used for the drossing to change the dross into a flux. Okay, that dross may be converted into a flux. So this is one of the method which has been used. And by mechanical process, the dross is placed into a press. You can then the quenching or the pressing or the rollers, okay, to a thin sheets, or it may be cut into a small aluminum rich particles, okay, and it can be reused for the melting in the furnaces. So this is all the two methods how the drossing is been used. Okay, so this is what the simple thing related to the drossing, which is generated in the maximum non-ferrous metals, and how it is been recycled, reused, okay, and how to reduce this drossing, that you have studied in the drossing one. Okay, now gas absorption in the aluminum casting. So see, when you do the casting, obviously the furnace is required. When there are so many, just in this model only, in the previous class I have told how the gas has been absorbed and what are the limitations of the gas in the furnace. Gas is been dissolved in the furnaces, and what is happening in the furnaces, okay, how the gas has been occurred. So there are so many variables are there for the absorptions of the gases. Okay, but for the degassing, for removing of the gassing in the gas absorption in the aluminum casting, there are two methods they are using, one in the fluxing and another one in flushing. So the flushing is a common method, just in the previous classes also you have studied. Okay, in a small crucible cup is there, in which the liquid molten metal is being poured. Okay, with the graphite tube, the hydrogen or gas is been, which is non-soluble, which is soluble in the aluminum. Maximum time the hydrogen gas is been used, which is been supplied in that liquid aluminum gas, and which carried out the remaining gas which has been absorbed in the aluminum, take out and come out in the sense of an bubbles at the upper surface of the liquids and directly escape to the atmosphere. This is how the flushing is been done. Simple construction, in the previous class you have seen how the flushing is done. Only the inert gas argons are being used in the ferrous, in the non-ferrous the hydrogen is being used. Okay, so this is the difference. The flushing means fluxing. Now let us see how does the fluxing works. The fluxing means adding a suitable agent in order to achieve the following: to react with the dross so that it can float at an up, to prevent the reactions of a melt. Okay, so some of the chemicals are been added in a liquid, so whatever the dross is there, that will come at the upper side, that is corrosion fluxing. To prevent and reaction of a melt of an aluminum with the atmosphere by acting a barrier to absorb the impurities in the melt. So the all the aluminum alloys in general are melt under the flux over the held salt. This flux contains a salt mixing, that's are the liquid at a normal aluminum melting temperatures. Okay, the other cover flux contaminants includes the aluminum and the zinc chloride. Some manufacturer of the cover flux recommended that the flux should be stirred into the melt to be an effective, so that the dross can be easily separated from the metal. So it has put into the liquid metal and it has been stirred with any of the thing. Now let us see in the stirring of the casting is there. Over there you can see it has to be stirred over there, so that whatever the dross and the impurities are there or the gases are there, that will comes and float on the upper surfaces. Okay, so 4.5%, 47.5% sodium chloride, which can be used as a flux, 5% of sodium aluminum uh, fluoride, which can be used as a flux, 47.5% of sodium chloride, which can be also used as an flux. Okay, now next we can see the grain refinement in the aluminum alloys. The grain size and fine, the grain size in the aluminum. So see, in the aluminiums the grain Size, okay, the grain size in the aluminum alloys refers the size of the individual aluminum crystal in the solid part. The size of this crystal is directly related to the numbers of grain or a nuclei forms during the initial stage of the solidifications or during a pouring of a metal. So see, the grain size of an aluminum when it comes in the casting, it depends on the solid part, okay, the first scrap material, scrap which are the furnace charge, which are raw material which are going to be made, it depends on that, okay, the nuclei, okay, and also the alloys which are been added for the desiring properties, on that also it is depend the development of the nuclei and the grain size. Okay, there are some of the what you can say, also the mechanical properties are generally enhanced with the fine grain structure. Obviously, if the grain structure are very good, the mechanical properties are also good. Okay, the grain size in the aluminum alloys can be preferred by the following three methods: thermal method, chemical method, and mechanical method. Now let us see what are the thermal method, chemical, to control the grain size and in the proper size. Okay, the more number of the grains, fine grain size will be therons having the ability to promote the improve casting as a soundness, okay, and the shrinkage, hot cracks. Okay, if the grains are increased more, the grain size are increased more, so it can be produced soundless casting, means what a good casting which is a defectless, like shrinkage, hot cracking, and hydrogen porosity, that is in gas porosity. Okay, to control the grain size there are three methods are being used: the thermal method, chemical method, and mechanical method. Now let us see the thermal method. The thermal involves the rapid cooling, chilling of a liquid subsequently. So see, in the thermal method there is a rapid cooling is there, often chilling, so that the rapid cooling the grain the nuclear generation rate will be more. Once the nucleus are generated, the atoms and the molecules also improves and the grain size will increase in the faster rates. For to increase the rate of a nuclear generation in a faster, the rapid cooling is done, that is a chilling means what, cooling any of the liquid uh, or the any of the rapid you can say, in previous class you have seen external and the internal chillings are the same. Aluminum particles are being placed in the mold so that it can absorb or extract the heat from the molten metals and release it to the atmosphere in a faster rate than the natural cooling. And the external cooling is that where the mold box is there, for that mold box some of the water is been sprinkled or the coolant is been sprinkled, so that the wall surrounding area, the mold box surrounding area temperature will be decreased or cool down, and it can transfer the heat through it or absorb the heat through it and extract the heat through it, so that the rate of the cooling can be done in the faster rate. So this is one of the methods, so that the grain size can be improved. Now chemical methods, the chemical method involves the additional some elements called the grain refiner to promote the nucleation. Over here what they do, some of the chemicals are being puts for the promoting means what, generation of more numbers of grains, okay, in hindering crystal growth. So which are the chemicals commonly particles are being used? Aluminium bentonite is a master alloy to the liquid melt before the casting, so it has been put in the liquid before the casting during the pouring purposes, so that it increase the more number of nucleations and generate the casting. The third one is the mechanical methods. Mechanical method, the mechanical refining methods involves the stirring or ignition. So now let us see what is the stirring is that. So the continuous rotating of that liquid metal, okay, by which the heat is been removed out from that liquid, okay, or extracted from that liquid, and reduce the temperature of the cooling, reduce the temperature of that molten metal. Okay, now let us see the stirring of the casting. So these are the three methods which are being used for the generation of the nuclei, by which the grain has been uh, generated, refinement is been done in the aluminum alloy and makes the mechanical property stronger one. Okay, so these are the three methods. Now let us see the stirring of the castings. The so see, you can see over here, this is a simple diagram is there for the stirring of an casting. Stirring of and casting. See over here there is a crucible is there, which is having at the bottom a small hole is there from where the liquid molten metal is being poured into the mold cavity, okay, or in the ladle you can have. This crucible or this ladle is this is a furnace, okay, this is a total assembly furnace in which there is a crucible is there, and this crucible is been surrounded by the electrical coil, okay, and at the middle you can see there is a stirrer which is been rotated around and stir the, over here there are the wings which stir the molten metal, okay, and over here there is a pipe which is connected to the gas cylinder where the gas is been released or uh, inside the molten metal, okay, this is the argon gas. Now what is the procedure and how does the stirrer works, and this is been used for removing the degasification, okay, it is used for the method of removing the degasification at a time, and also it is been used to reduce the cooling temperature so that the new generation of the nuclei can be done in a faster rate and the grain size may be increased, okay. Now let us see the operation. So see, the power is being supplied. When the power is being supplied, the current is being supplied within that coil. With that coils, this work like an induction furnace. Within that coils, the electromagnetic force is being generated. With that help of the electromagnetic force, the eddy current is generated over here, okay, and the heat is been produced to the crucible. With that help of that heat, the metal starts to melt over there. Before it is in a liquid state, that is in a solid state, it starts to convert into a liquid, starts to melt over there. When the complete aluminium ferrous material is non-ferrous material is completely melt within that crucible, then the stirrer is being placed over there. The stirrer starts to stir that total liquid totally in a round condition, as well as the eddy current is also generated. With the help of this eddy current, the stirrer action is also generated inside the liquid metal, okay, liquid of non-ferrous metal. It also allows the liquid fluid to rotate inside that crucible. So both the stirrer and the eddy current alloys are being rotated inside that one, due to which the degasification is in also coming out, the gases which are inside there are also coming out, and field is when gases are also coming out, and it will also reduce the temperature of a liquid before pouring, okay, which makes the generation of a liquid or a solidification in the faster rate, and also supply the argon gases to the liquid flow so that the gas can be carried out, okay. In inert gas like an argon is in used to carry out the gas with an assist injection. So whatever the gas are been enclosed within this liquid are being carried out by this inert gases, that is argon gases, and comes at the atmosphere and escapes comes at the upper surface of the molten metal and escapes in the atmosphere. So this is how the degasification is being done, stirring by the stirring and inserting the inert gas, as well as the temperature reducing just now we saw the grain refinement or the reinforcement is been done by the generation of a more nuclei is been done by the stirring casting setup, okay. This is how it has been done. So what are the advantage you can see in the stirring casting? The stirring action with the molten metal helps in easy mixing, the melting of an alloys, okay, as well as the homogeneous of the temperatureness throughout the furnace lead to a sound casting, okay. Sound casting means what? Strong grains, okay. Stirring action can help removing the hydrogen gases. So hydrogen gases which have been entrapped in the aluminum are been removed out by the stirring action. So degasification is also doing. Eliminates the porosity. Eliminates the porosity means what? If the gas is been removed out, it doesn't entrap the gas in the liquid, so it reduces the porosity over there, okay. Defects. Now disadvantage, equipment is very costly, okay, so this is very costly. Expensive stirring can increase the gas pickup furnace link wear and oxidization of an alloys. Okay, it is an excessive stirring. If you do an extra stirring, what will happen? The gas can increase the gas pickup. All the gases will come out the furnace linking wears. Okay, whatever the furnace links are there, they may be worse, and oxidization of the alloy may occurs in a faster rates. Okay, so this is a major disadvantage. Monitoring the inert gas to an atmosphere is an additional requirement. Okay, so whatever the gas are been released to an atmosphere, inert gas is there. Okay, to an atmosphere is an important, that also has to be consideration. Not only the inert gas is coming out, but with that, whatever the trap gas, hydrogen gas, is not only has to remove out, with that the whatever the inert gas is been released, okay, that also has to be come out with that hydrogen gas, that also has to be monitored. So this is what the major disadvantage of the stair gas. Okay, so now dear students, over here your third module of an solidification and non-ferrous foundry practice is been conclude over here. Okay, so by this concept we are winding your total syllabus of third semester metal casting and welding process subject. So all the 5 models I have covered today of your syllabus. Okay, so from the next classes we will go for the revisions of the subject. Okay, so if you are having any doubts regarding this one, please comment me on your WhatsApp group, so I will clear the doubts. In the next classes we will go with the revisions. Okay, thank you for joining.